This section 2.5 is all about solving differential equations using substitution. So we're going to talk about how we use substitution to help us solve differential equations, and then we're going to write a list of the really common types of substitution we'll be using so you kind of have them all in one place. But those things will be using proportional variables, solving like Bernoulli's equation type problems, or using linear combinations. And we'll do examples of all those things as we go. I just want to reiterate before we get into that, though, that I need you all to send me requests for integral or exam 1 type questions and examples that you want me to make supplemental videos over to help you kind of get into the swing of the tools that we use and prepare for your exam. I haven't gotten any of those yet, so send me something if you want one of those videos to happen. The thing that we're going to start out talking about substitutions today, though, is going to be sort of how do we use substitutions. And so the general idea for this section is going to be that we're going to use some kind of change of variables in order to turn any ODE we have that we don't necessarily know how to solve into one that we can solve. And when I say a differential equation that we can solve, I'm talking about the tools that you've learned up to this point. So something that's linear or separable like that. And so that's what substitution means in general. And to build intuition for how it works, I think it helps to think about the type of substitution that you've used most recently probably is U substitution, as you learned it in your Calc 2 classes, and it comes up in some of the integrals that we have to use. So if you have something like 2x natural log of x squared plus 1 dx, you have something that's hard to solve. And then what you do is you substitute u equal to x squared plus 1 so that you have ln of u. And then you have to sort of change all your variables. So you also take du equals 2x dx, and then you just kind of plug it in and you have ln of u du, and that one's easy to solve. And so the important thing here is that you don't forget your derivatives. And so for differential equations, your steps are going to kind of mirror this. So you're going to start out by identifying a good substitution. And on the next page, we'll kind of talk about what that means. But once you've identified your good substitution, you're just going to plug in the substitution. You're going to plug in derivatives that use the same variable. And then you're going to solve an easier problem. And so hopefully you can see how those steps mirror what you're used to when you do a U substitution problem with integrals. And I just want you to really remember this part. It's the one thing that I think tends to go wrong in this section is you need to remember that when you do U substitution for integrals, you plug in du. So when you do substitution for differential equations, you plug in derivatives. And then right here, we're going to just list out the different types of substitutions that we'll be talking about. because I think it'll help to have like right next to these steps, the different substitutions that you'll check if you can use when you run into a particular problem. So there's going to be 3 that we do. I'm going to do this and say, okay, there's our 3. And I'm going to write what they are and then kind of how you know if you can use them. So the first is to do y equal to u times x, or x equal to v times y. And I called that like proportional variables. The second is going to be the type that you use to solve Bernoulli equations. So that's going to be using something like u equal to y to the 1 minus n. And then the last one is going to be sort of linear combinations. So that's going to be u equal to a times x plus b times y plus c. Those are the 3 things we're going to go over, and then what I'm going to do is write kind of how we'll see when to use those, and then in our videos we'll actually practice using them. So for y equals ux, or x equals vy, we're going to use this if you see terms like x to the p or y to the p for any power p in your ODE. Or, in your ODE in differential form. Or if you see a lot of like x over y in derivative form. Differential form being that thing that we used a lot in exact equations where you have dx plus dy equal to 0 and there's some stuff in front of everything. And derivative form being more like what we saw for separable and linear equations where you have dy dx plus some stuff equal to some stuff. The second substitution, u equals y to the 1 minus n, you're going to use specifically for something called a Bernoulli equation. So that's going to be something of the form dy dx plus some p of x times y is equal to f of x times y to the n. And that n right there is the same n as you use in the substitution. And this is Bernoulli's equation for some function p of x and some function f of x. And then the last one, the linear combination, you're just going to use if you sort of see or can write your differential equation as dy dx equal to some function of that linear combination. So this one I think looks the most like what you're used to from u substitution, like if you could write 3x plus 2y plus c, should change that, plus 7 squared. This you would identify sort of as a u substitution type thing to do. So those are the 3 different types of substitution we'll be talking about, and the way to identify when to use them. And all we're going to do for every single one is we'll start with a differential equation. We're going to identify which of these 3 things is good. We'll plug in the u we had, and we'll change our derivatives to be in terms of u, and then we'll solve something easier. So we'll start off with that proportional variable thing next.